Thursday, so just a recap, Chapter 3, we're starting out just reviewing how to solve a system of equations. And Thursday, we looked at solving a system graphically, so we looked at making a table as well as graphing systems. Today, you want to be able to solve a linear system algebraically. There's two algebraic methods, substitution and elimination. So you have seen these methods before. I'm still going to be going through some examples, and then other examples I'll have you work on either individually or in your groups. One thing to point out before we go through the first substitution method is that algebraic methods are used to find exact solutions. So I think I mentioned this when we went through the graphing method, is that when you're graphing, first of all, you want to be precise, or as precise as you can be when you graph your lines. But sometimes, say it intersects and it's not exactly at a point that has integer coordinates. It's kind of in between. So rather than guessing where that is, you can use an algebraic method to find the exact solution. And just like I mentioned, or I think I mentioned on Thursday, you are on the quiz and on the test being asked to show that you know the methods. So we are going to go through the substitution method first to make sure in the notes, in the practice, on the quiz, if it says to use substitution, that is the method you are using. So when it says a specific method, I'm not just checking your answer, I'm also looking at your work, and if you don't use the right method, you're losing those points for not showing the correct method as well. So you do need to practice and know all the methods, and then ultimately if I just ask you to solve, you can use whichever method you'd like. But for substitution, so just kind of reading through the steps here, and we'll go through the first example together. Sometimes step 1 is already done for you, and if it's not, you need to solve one equation for one of the variables. And if you want to make a note to yourself, x or y, because of slope-intercept form needing to be solved for y, so often students get in their minds, if I solve for a variable, it needs to be y, and you forget that you can solve for x. So you can solve for x or y in either equation. So you really have 4 choices because usually both equations have an x and a y. So you just have to solve for one of the variables and then substitute that resulting expression into the other equation to replace the variable and solve for that variable. Once you have that value, x equals or y equals whichever number, substitute it back in to one of your equations to solve for the other variable. And remember, too, to write your answer as an ordered pair. So you are finding both variables, writing your answer as an ordered pair. Even though we're not graphing, the answer is still where the lines would intersect. So if we look at example 1, here is our system of equations. Looking at those 2 equations and the 4 variables that you see, which one, well, first of all, let me say this, because sometimes this is confusing as well. Neither of these equations have a variable that is solved for. Solved for means it would be x equals or y equals. Neither of these equations have that. Which variable would be easiest to get by itself? X in which equation? The top one. So look for whichever one is easiest. Certainly I could solve for any of these, and as long as all of my math is correct, I'll be fine. But if you don't have to deal with fractions or decimals, don't. Make it easier on yourself. So if I want to solve this top equation for x, I would have to add 7y to each side. And I would get x equals 7y plus 11, or 11 plus 7y. That is step 1. And then step 2 would be to substitute this expression that x is equal to into the other equation for the x. So in my second equation, I'll have 5 times, in parentheses, I'm replacing x with 7y plus 11. Everything else stays the same, so then plus 4y equals negative 23. And now notice in this equation, I know I have two separate terms that have y, but I only have one variable. So now I can solve this equation for y. I don't have both an x and a y. What would I need to do first in this equation to solve for y? Distribute the 5, yes. So I would have 35y plus 55 by distributing. Bring down the plus 4y equals negative 23. So get rid of parentheses if you have them. And then the next step, what could I do next to solve for y? I could subtract 55, and actually I'm going to combine a couple of steps here. Subtract 55, and then the two terms I have left on that left side are both y terms. I can combine them. So 35y and 4y combine to be 39y. And then I have negative 23 minus 55, so negative 78. And then divide by 39 to get y is equal to negative 2. So make sure that you're not stopping here. This is not your answer. I still need to find x. So now this is step 3. I take the y value, and I could go back into either of my original equations, but what's easier is if I look at the equation I already solved for x, and I substitute the y value into there. And that way I'm not re-solving for x. So if y is negative 2, x will equal 7 times negative 2 plus 11. And then just evaluate the right side. That would be negative 14 plus 11, which is negative 3. So x is negative 3. And then please do not circle the x value, circle the y value, and make it look like you have two answers. Your answer is the ordered pair. It's where the lines would intersect. Even though we're not graphing it, that's what it represents. So write it as an ordered pair. This would be negative 3, negative 2. Okay, questions on that example? Okay, then here's what I'm going to do today. It's going to be a little different than what I've done before, or rather I just haven't done this. So I'm going to have you either individually, and then you want to compare with your groups or just work on it together in your group, do example 2. And what I'm going to do is when I walk around to check, if I see that your group has it right, I'm just going to ask one of you from the group. I'm not going to pick who has to do it. I don't like pointing people out that way. But one person from a group, and I'll have different groups each time, and not every group is going to be picked today. But one person in that group, just bring your sheet up once I'm all the way around the room, once everybody's had a chance to work on it. Show your work and explain it. And that way, you're not just hearing me explain things every time. You can see how different students have explained things as well. So realize though, when you come up, you're just bringing up your sheet. You already know you have the right answer, so I'm never going to tell you to come up if your answer's not right. I'll still answer questions if you have them. And then every group, at some point is going to be picked. And even if I pick your group twice, I would ask a different person to come up. It's not the same person every time. So do example 2. I'll come around and check, and once I get all the way around, I'll kind of pick a group to have a volunteer to come up and explain number 2. And certainly if you get done with number 2, you can look at number 3. Remember that it's possible to the solution so all right, Lynn is going to show what she did for number 2 and then just explain it so her answer is right so you can check with what you have. And then if you have questions, let us know.
Okay, so I chose the bottom one because it was the easiest. So then I just minus 2x on both sides. So then I got y equals negative 2x plus 7. And then I just substituted it into the top equation. So then I got 5x minus 3. So that would be, the whole thing would be 5x plus 6x minus 21 equals 23. And I just plus 23 on both sides. And I had 5x plus 5x equals 44, and I had 11x. And then I just divided 11 on both sides, and I got x equals 4. And then I just plugged in 4 for the original equation I got, and then I got y equals negative 1. So then our plot would be 4, comma, negative 1.
Were there any questions on number 2? 4, negative 1. Thank you. Okay, so that's what I'm looking for. If I say, somebody in your group come up, that's all you have. That's all I'm looking for you to do, just hearing other explanations. We are going to skip ahead to the next method, but I know some of you were working on number 3, so if you want to check your answer for 3, this is the correct answer for number 3. So if you did number 3, check it. If you didn't get it right and you don't figure out why, I can help with that as I'm walking around. All right, but for the elimination method, depending on some Algebra 1 curriculums call the elimination method something different. So if you haven't heard elimination before, but you've heard linear combination method, they're the same thing. The whole goal, though, if you really think of the names of these methods, when you solve by substitution, your second step is substituting. That's why it's called substitution. If you're solving by elimination, our second step is eliminating a variable. So the method kind of tells you what the whole goal of the method is. So the elimination method, again, sometimes step 1 is already done. If not, you have to do it. But this is where you multiply one or both equations by a number. And if you're multiplying both equations, the number that you multiply by does not have to be the same. So for example, you could multiply the top equation by 3 and the bottom one by 5. But you're multiplying one or both equations by a number to result in two equations that contain opposite terms. So your first step is to make sure one of your variables in your system has opposite terms. Opposite means one's positive, one's negative, and when you add them together, it equals 0. They cancel out. So for example, if you have positive 3x, the opposite term would be negative 3x. They add to be 0. Or negative 2y and positive 2y. So sometimes your equations already have opposite terms, which means you can move on to step 2. Step 2 then is to add the equations, and when you add opposite terms, they equal 0, they cancel. This eliminates one of your variables. You then solve the equation that you're left with for the other variable. And then the third step is the same as the third step in the substitution method. You find the value of your other variable by plugging that value back in. So if we look at example 4, now some of you I know have been working ahead on these as well. If you already looked at example 4, maybe I'm going to explain it a different way. I realize there's kind of two different ways you can do this one. So what I check for first is that in your system, everything is lined up. So the x's are lined up, the y's are lined up, the equal signs line up, and then the constants line up. If things aren't lined up, you want to rearrange it so that they are lined up. Second thing I look for is, do any of my variables have opposite terms already? So positive 6x and positive 4x are not opposites. They don't add to be 0. Negative 5y and negative 5y are also not opposites because they don't add to be 0. However, they're very close to being opposites. In order to be opposites, one of them would just need to be positive. So what I'm going to choose to do is I'm going to choose to eliminate the y's, and I want one of these to be positive 5y. So what would I multiply a negative 5y by to make a positive? By negative 1. And I could do that in this case to either equation. So let's just say the bottom equation I choose to multiply by negative 1. So I'm going to leave the top equation the same, 6x minus 5y equals negative 8. And make sure on the bottom equation I multiply everything on both sides. So my positive 4x will now be negative 4x. My minus 5y will now be plus 5y equals, and my negative 12 will now be positive 12 when I multiply by negative 1. And now if I look at my y terms, I have negative 5y and positive 5y, they're opposites. So now when I add my two equations together, this is step 2, my y terms will cancel out because they equal 0. And then I make sure to add everything else. So I have 6x plus a negative 4x would be 2x. Bring down the equal sign. Negative 8 plus 12 is 4. And I get the equation 2x equals 4. I can solve for x by dividing each side by 2. So x is 2. Now once I have x, go back to one of your two original. I would just recommend not plugging it into the equation you changed, but one of the two original, doesn't matter which one. Substitute in the x value of 2 and solve for y. So let's say I just substituted into the top one. So I would have 6 times 2, that would be 12, minus 5y equals negative 8. And then solve this equation for y. So subtract 12 from each side. Bring down the negative 5y equals negative 8 minus 12 is negative 20. Divide by negative 5. and y would be positive 4. So then the ordered pair is 2, 4. Okay, now some of you, for this particular one, I showed it this way on purpose with multiplying one of the equations by -1. If you worked ahead, this could also be solved by subtracting the terms. I don't know if anybody worked ahead and did that. Grace, you did? Okay. So if you see that the two terms are the same, you could have subtracted them, but then you have to make sure you also subtract everything else. So it's kind of like whatever, whether you're using addition or subtraction to cancel out the variable, you have to do that same operation to everything else. So same thing, I want your group to work on number 5, and if you get done, you can move on to number 6, but work on number 5. I'll kind of pick a group that I see as the right answer and ask one of you to explain what you did. But everybody work on number 5. All right, Luis is going to explain number 5. So just for this one especially, make sure how you wrote your answer is correct. She does have the correct answer up here.
Okay, so for 5, we decided to multiply with -3. And then it's minus 6x minus 9y equals -15. That means that 0 equals 0, and that means it's the same line because it's true. So it has infinitely many answers.
Just leave that up there for a moment. So I saw some different things, and this is between my last hour and then this class as well. So when you get 0 equals 0, everything completely canceled out. The answer is not 0. The answer is not the ordered pair 0, 0. Those were a couple things I saw. The answer is not the infinity symbol. Remember, I've talked about that a few times now. You have to write infinitely many. If you had an equation, say the left side canceled out and you got 0, but on the right side you got the number 2 or something like that. So 0 equals 2. That is a false equation. That would mean you have no solution. Okay, so it should be infinitely many. Thank you. And if you haven't already in your groups, take a look at number 6, same thing. I will come around and check those and then just be asking a group to pick someone to explain it. Okay. So you might need to multiply both equations by different numbers to get the variables to cancel. No, you can do the top equation by one number and the bottom equation by a different number. Does that make sense? Yeah, they don't both have to be by the same. Ethan's going to explain number 6. You can check your answer for 6. And keep in mind, too, if you did something different and still got the same answer, if you have questions, though, just because I'm not showing it this again, you can't ask questions. So please give Ethan your attention.
So the top one I times it
All right,
by 2.
hold on. Quiet, please, as Ethan's explaining.
The top equation I times it by 2, and then bottom equation I times it by 3. And the top one, once times by 2 is 16a minus 6b equals negative 22. And bottom one, once times by 3, 15a plus 60 equals negative 9. And then you just add them. And it's 31a. And so 60 they cancels. So they equal 0. And then equals negative 31. And divide that by 31. And a equals negative 1. And plug I plugged negative 1 into the top one. 8 parentheses negative 1 minus 3b equals 11. Distribute a is negative 1. And then it's 8, then negative 1. And then it's negative 8. And plus 8 to negative 11. Minus 3b equals negative 3, and then 5 negative 3 to each side, and use 1.
Okay.
And
And keep this in mind too, when you have variables that are different than x and y, in your ordered pair, the variables are still in alphabetical order. So for a and b, in the ordered pair, a will come before b. So use that judgment for any of your variables. We are going to skip going through 7 together. But if you already did 7, I know a lot of you are working ahead. 7 is another one that is infinitely many solutions. What I do want to discuss, though, is question 8. And I have a couple things to talk about with question 8. 8 is just one where I'm looking for more of a written response. I haven't talked about this specifically yet, but I have this up here, and I'll put one in the back too so you can see it a little bit easier. When you are writing a response in math, what I am going to be looking for from this point forward in terms of grading it, if it's on a quiz or a test, is one, that you're answering the question completely and accurately. That would be a point. So I need it quiet, please. 2, that you're using math vocabulary appropriately. And 3, you're following proper English conventions, so you're using complete sentences, capitalizing, punctuation, that sort of thing. So that's what I'm going to look for 8. And again, I'm still going to go around, choose a group, have somebody explain what they wrote for 8, and I can check it before you come up here. But it says, think about the methods you learned. Why is substitution sometimes more helpful than elimination, and vice versa? So think about if I just gave you a system and I said solve it. I didn't tell you what method to use. When would you prefer to use substitution versus when would you prefer to use elimination? So just think about when one method would be better to use than the other one, because ultimately they're both going to give you the same answer. So when would you use which one is what I'm looking for. So again, I am going to, that's something you should discuss as a group. Write down a response, and then I'll pick a group, have somebody explain their answer. All right, for the written response for number 8, Lexi's going to show what she had. Obviously, you would not have to have exactly what she wrote, but she does have a good response.
Okay, so substitution is sometimes more helpful when one of the equations gives you what x or y equals, and then elimination is sometimes more helpful when you already are given two equations that have opposite terms.
All right, so she, I would say, followed those 3 and she used the vocabulary, just thinking about when you might use each method. Your assignment is included at the bottom.